a water droplet the size of the moon fell to Earth? This might not be a question everyone thinks of, but it is extremely interesting. It's important to know that in reality, water droplets the size of are larger than Earth. These include some moons of Jupiter and Saturn, such as Europa and Enceladus.
Europa is covered by a crust of ice and water with a rocky core in the center,
while Enceladus is much smaller than our moon, but its amount of ice and water is relatively large.
Additionally, Pluto, once one of the 9 planets, smaller than the moon, also consists largely of water ice.
Europa is the 6th satellite, counting by orbit from the inside out of Jupiter. The satellite Europa was discovered by Galileo Galilei and Simon Marius in 1610.
These two scientists may have discovered this satellite at the same time and independently.
Among the 4 large satellites of Jupiter discovered in 1610, Europa is the smallest. Enceladus is the 6th largest satellite of Saturn, discovered by astronomer William Herschel in 1789. Before the 1980s, little was known about Enceladus except that its surface contained water.
Enceladus has a diameter of about 500 kilometers, 1/10 the size of Titan, Saturn's largest satellite.
So, what would happen if these water droplets fell to Earth? Many people might think this is a disaster similar to the extinction of dinosaurs on Earth. But in reality,
this association is not entirely accurate, because the asteroid that fell to Earth at that time was only about 10 kilometers in diameter.
While among the celestial bodies mentioned above, Enceladus is the smallest,
but still has a diameter of over 500 kilometers.
Under the influence of Earth's gravitational acceleration,
these giant water droplets would accelerate to about 11.2 kilometers per second,
regardless of how they fall from distant space to the ground. Thus, if a water droplet the size of the moon fell, you can imagine how catastrophic the consequences would be for us. However, some might argue that these moons and asteroids are not actual water droplets.
And if there were a water droplet the size of the moon, the phenomenon might differ from that of a meteor. In physics, gravitational acceleration is the acceleration due to gravity acting on an object. Like velocity, gravitational acceleration is a vector quantity, ignoring friction due to air resistance, according to the equivalence principle. All small objects experience the same acceleration in a gravitational field relative to the center.
This holds true regardless of how
The objects differ in mass and composition.
Nevertheless,
what is the difference between an asteroid entirely made of water at 11.2 kilometers per second
and other objects when falling? The moon's diameter is over 3,400 kilometers. When water droplets coalesce and reach such a size,
they would also take on a spherical shape under the influence of gravity.
When they fall to Earth, the collision would certainly eject a large amount of material into orbit, perhaps similar to the collision between Theia and Earth in the past. Theia is the name of a hypothetical planet.
According to the giant impact hypothesis of moon formation, it collided with Earth about 4 billion years ago.
This collision, with only a glancing angle, was enough to destroy Theia. Its iron core was buried in the primordial Earth, but some also believe such water droplets would fall like rain and could cause floods. Earth's atmosphere is about 80 kilometers high, while a moon-sized water droplet has a diameter of 3,400 kilometers, so this idea is completely unfeasible. In reality, if a true water droplet the size of the moon fell to Earth, what you should do then is pray for some mysterious force to slow it down so it doesn't collide directly at high speed. However, even that would be futile because the moon's volume is 22 billion cubic km,
while the total seawater on Earth is only 1.34 billion cubic km.
The amount of water falling would be 16 times the total water in the oceans, so this is not simply a flood,
but a massive body of water that would destroy and submerge everything. All land on Earth's surface would be swept away, including Mount Everest and the entire continent of Australia. All tectonic plates would be crushed, and global earthquakes would occur continuously.
Volcanoes across the planet would erupt incessantly. Earth's surface area is only 510 million square kilometers, and when a water droplet the size of the moon.
With 22 billion cubic kilometers of water falls on our planet.
It means a layer of water up to 44 kilometers thick would cover Earth's surface. Earth would become a sphere with a surface entirely of water.
So seismic and volcanic activities would only occur underwater, and Earth's surface would be relatively calm.
For humans, it is estimated that no one would survive, and the same goes for other organisms.
Surviving organisms might include some plankton and microorganisms in the sea.
And Earth's entire ecosystem would begin to evolve anew.
3 billion years ago, Earth was entirely water.
Recently, scientists have found evidence that 3.2 billion years ago, our planet was covered by a vast ocean with no land. Later, continents emerged as tectonic movements pushed massive rock masses above sea level. This evidence is preserved in ancient ocean floors, now barren, desolate lands in northwestern Australia. About 4.5 billion years ago, high-speed collisions between cosmic dust and rocks formed the core of our planet. It was a sphere of molten, bubbling magma deep within the Earth for thousands of kilometers.
This sphere gradually cooled as it rotated, and finally, after about 1,000 to 1 million years, cooled magma formed the first mineral crystals in Earth's crust.
Meanwhile, the first water droplets might have been brought to Earth by icy comets. These comets came from outside our solar system. Water could also have arrived on Earth via dust particles from clouds that birthed the Sun and other planets orbiting it during Earth's formation.
Associate Professor Benjamin Johnson of the Department of Geological and Atmospheric Sciences at Iowa State University, USA.
When Earth was a molten magma ocean, water evaporated and gases rose into the atmosphere.
Then rain fell from the atmosphere once the ground cooled sufficiently. From this research, we don't know exactly where the water came from, but it could be from any source.
Water was present when our planet was still a magma ocean. In this new study, Professor Johnson and co-author
Associate Professor Bothwell Wing, a geoscience expert at the University of Colorado Boulder, US, focused on Australia's remote Pilbara region, which preserves a hydrothermal system from 3.2 billion years ago.
And features of the entire crust being an ocean from surface to deep bottom with thermal energy creating circulation cycles. Recorded in the rugged seafloor are oxygen isotopes.
Over time, the relationship between these isotopes helped scientists decode changes in ancient ocean temperatures as well as global climate. However, scientists also discovered a surprise when analyzing over 100 sediment samples.
That 3.2 billion years ago,
the vast ocean contained more oxygen-18 than oxygen-16.
While today's oceans contain more oxygen-16. Computer models show that, on a global scale, continental masses remove oxygen-18 from oceans. Without continents, oceans would be richer in oxygen-18.
And the ratio between these two oxygen isotopes indicates no continents existed at that time.
Previously, researchers believed Earth was once covered in water. But they disagreed on the area of land above the ocean. The recent discovery reveals actual geochemical conditions regarding land above sea level.
The hypothesis of an ancient water-covered Earth also raises the possibility of a new question.
Which is where the first life forms appeared on this planet and how they evolved.
Professor Thompson says there are two major cradles for the origin of life: hydrothermal vents and terrestrial hydrothermal ponds.
If our research results are accurate,
then the number of terrestrial environments for life to thrive and evolve was extremely small, or even did not exist until as late as 3.2 billion years ago.